तो बच्चों पिछले लेक्चर में हम लोगों ने सब्सट्रैक्शन ऑफ वेक्टर बताया था, जिससे मैंने ये कहा था आपको कि अगर ये वेक्टर r है एंड दिस वेक्टर r इज रोटेटेड थ्रू थीटा एंगल without change in magnitude, then what is the change in vector? So this is vector r dash because its direction is different. So this r plus change, that is delta r, is r dash. R plus delta r is r dash. So the change in vector delta r is r dash minus r. This is final vector, and of course this is initial vector, and this is r dash plus minus r. If the angle between r and r dash is theta, then delta r is the resultant of delta r is the resultant of course r and r dash, of course, but not at theta, rather at 180 minus theta, and it was calculated like that. When we draw the perpendicular bisector, this is theta by 2 and sine theta by 2 is equal to delta r by 2 divided by r, and it is 2r sine theta by 2. So the change in vector is 2r sine theta by 2. If a vector r is rotated through theta angle without change in magnitude, the change in vector is 2r sine theta by 2. On this concept, various problems can be solved. It has large number of application in mechanics, especially in for example, if a particle is moving towards east with a velocity of 10 meter per second, particle is moving with a velocity of 10 meter per second, and after certain time it changes its velocity and is of course moving with a velocity of 10 meter per second 60 degree north of east. If the particle is initially moving with a velocity of 10 meter per second towards east, after certain time it changes its velocity and is moving with a velocity of 10 meter per second 60 degree north of east, 60 degree north of east. What is the change in velocity? So if only magnitude is calculated, तो magnitude का जो value होगा delta v is equal to 2v sine theta by 2, and it is 2 and that is 10, and sine 30 is half, and it is 10 meter per second. So as far as magnitude is concerned, it can be easily calculated by this concept 2r sine theta by 2. So any vector rotated through theta angle without change in magnitude, it can be easily calculated. लेकिन अगर हम लोग इसका डायरेक्शन भी निकालते हैं तब देखिए क्या होगा. This is the initial vector and this is the final vector. Change in vector is final vector minus initial. Final vector minus initial vector. Initial vector. So this is your initial vector and this is your final vector, and the angle between two is, this is 60. This is final vector and this is the initial vector. The particle was initially moving towards east, finally it is moving 60 degree north of east. This is final and this is initial. So this is minus initial, and the change is the resultant of this 10 meter per second, 60 degree north of east, and this 10 meter per second. Now the initial was 10 meter per second towards east. The negative of initial is 10 meter per second towards west. So it is 120. And we have already calculated in vector that if two vectors are added at 120 degree and if their magnitudes are equal, the resultant is also 10. And the resultant of two equal vectors bisect each other. So this is also 10 meter per second, my dear. And bisect means it is 60 degree north of east. 60 degree north of east. 60 degree north of west. 60 degree north of west. This is north and this is west. So 60 degree north of west, or 30 degree west of north. So both magnitude and direction has been calculated. In the similar fashion, the second problem, if a particle is moving with a velocity of 10 meter per second towards east, 10 meter per second towards east, after certain time it changes its velocity and again it is moving with a velocity of 10 meter per second towards north. Calculate the change in velocity. Calculate the change in velocity. Calculate the change in velocity. Change in velocity. So if only magnitude is to be calculated, then again it is 2r sine theta by 2. So the magnitude is delta v is 2v sine theta by 2. So 2v is 10 sine 90 by 2, that is 45, and it is of course 10 root 2. But if the direction is to be calculated, it is final minus initial. So this is the final and this is the initial. So this is minus initial. So this is final and this was initial. So this is minus initial. It is 10 and it is 10, and we know that the resultant of two equal vector at 90 degrees 10 root 2, and two equal vector always bisect each other. So again it makes an angle of 45 degree. So it is 45 degree west of north, or 45 degree north of west, or it is northwest, 10 root 2 northwest. Now we can easily calculate problem based on this concept. For example, if a particle is moving with a velocity of 10 meter per second in a circular path, in a uniform circle, and if initially the particle is moving towards east, what is the change in velocity in 1/4 rotation, 1/2 rotation, 3/4 rotation, and 1 complete rotation, and 1 complete rotation? So this is our problem, that if a particle is moving with a speed of constant speed of 10 meter per second in a circle. So this is our problem. The particle is moving on a circular path. Initially it is moving with 10 meter per second towards east. It is moving on a circular path. Now what is the change in velocity after 1/4, 1/2, 3/4, and of course after one complete rotation. So now 1/4 rotation, 1/4 rotation. So this is the initial velocity, 10 meter per second towards east. After 1/4 rotation, it will make an angle of 45 degrees. This is the final velocity, and again it is 10 meter per second. So the particle is moving with 10 meter per second without change in magnitude. So after 1/4 rotation, it has been rotated through 45 degrees, see 90 degree. It has been rotated through 90 degree. The change in velocity will be from that formula 2r sine theta by 2, 2v sine theta by 2. So it is 2 and it is 10, and sine 45 it is 1 by root 2. 90 degree, and of course it is 10 root 2. But if we want to calculate the direction also, this is the final velocity. It is moving towards north after 1/4 rotation, and initially it is moving towards east. A vector is invariant under translation. इसको मैं यहाँ ला सकता हूँ. It is moving with a velocity of 10 meter per second. Vector is invariant under translation. Change is final minus initial. So this is also 10. This is also 10. The resultant of 10 is 10, and 10 is 10 root 2, and again it is equally inclined. So it is 45 degree. So the velocity is 10 root 2 northwest. So in the 1/4 rotation, 1/4 rotation, the change in velocity is 10 root 2 meter per second northwest. Now after 1/4, change in velocity after half rotation, 1/2 rotation. This is the initial condition. The particle is moving initially with 10 meter per second towards east. As the particle is moving in a uniform circular motion, after 1/4 rotation, it is moving like that. It is moving like that. Again with 10 meter per second, but towards west. Now we want only the change in velocity. Then the change in velocity is delta v is 2v sine theta by 2. So the change is 180 degree. So it is 2 and it is 10, and sine 90 is 1. So the answer is 20 meter per second. If you want to calculate the direction also, then this is the initial and this is the final. Now a vector is invariant under translation. This is the initial velocity, 10 meter per second, and this is the final velocity, Vf, again 10 meter per second. The change is final minus initial. So if this is subtracted, this will again be like that. This is 10, initial is 10. If it is minus, then it is also. So Vf minus Vi is 10 minus 10, that is 20 meter per second, and 20 meter per second towards west. 20 meter per second towards west. The change in velocity is 20 meter per second towards west. If it is the 3/4 rotation, 3/4 rotation. So particle is initially moving like that, 10 meter per second towards east, 10 meter per second towards east. After 3/4 rotation it will be here, 1/4 rotation it will be here, 1/2 it will be here, and after 3/4 it will be here. So it has been changed its direction by 270. Now the change in velocity is final minus initial. This is initial. A vector is invariant under translation. So this is initial, 10 meter per second towards east. Change is final minus initial. Again this is 10 meter per second. This is 10 meter per second. The resultant is of course 10 and 10, 10 root 2, and it is 45 degrees. So 10 root 2 meter per second, it is south, and this is west, so southwest. Again you can calculate the change in velocity after, of course, one complete rotation. This is initial velocity vi, 10 meter per second, and after one complete rotation, again the angle is 360 or 0, 360 or 0. So the change in velocity is 2v sine theta by 2. So 10 sine 360 by 2, sine 100 is 0, so the change in velocity is 0. This is the initial and this is the final. So final minus initial is 10 minus 10, that is 0. So we can easily calculate the change in velocity if the initial and final, of course, velocity has been given. You can easily calculate. For example, if a truck is moving with a velocity of 10 meter per second towards east, 10 meter per second towards east, after 10 seconds it changes its velocity and is moving with 10 meter per second, what is the magnitude and direction of acceleration of the truck? If a truck is moving with a velocity of 10 meter per second towards east, and after 10 seconds it changes its velocity and is moving with a velocity of 10 meter per second towards north, what is the acceleration? Or first you can calculate the change in velocity of the truck. Say this is a truck. It is moving with a velocity of 10 meter per second. After 10 seconds it is moving with a velocity of 10 meter per second towards north. Initially it was moving with a velocity of 10 meter per second towards east. Time taken to change the velocity, so time taken is also 10 seconds. What is the acceleration? What is the acceleration? What is the acceleration of the truck? Now this is the final velocity, this is the final velocity, and this is the initial. Change is final velocity minus initial. Again this is 10 and this is 10. The resultant is of course 10 root 2. And it is north and this is west, so it is northwest. So the change in velocity is 10 root 2 meters per second, and the acceleration is delta v by delta t. So acceleration is 10 root 2 meter per second northwest divided by 10, so it is root 2 meter per second northwest. So we can easily calculate the change in velocity or change in acceleration or change in force by this concept. For example, if a particle is moving with a velocity of 10 meter per second towards south. Now it changes its speed, changes its velocity, and is moving 60 degree south of west. What is the change in velocity? What is the change in velocity? Change in velocity. So change in velocity can easily be calculated. Initially the particle was moving towards south. This is the initial velocity, 10 meter per second. Now final velocity is, say, 10 meter per second, 60 degree south of west. This is final. Now this is minus initial. This is initial, this is minus initial. It is 10 meter per second. Now what is the angle between these two vectors? So the change is the resultant of this and this is 120. The angle is 120. This is 10. This is 10. The resultant of 10 and 10 is 10 meter per second and will be equally inclined. So it is 60 degree west of 60 degree south of 60 degree south of west. So 10 meter per second, 60 degree south of west. So we have calculated, of course, the difference in two vector. If the magnitude of the vector is same, it only changes the direction. The change in vector or change in velocity can easily be calculated. Thank you. In some other lecture, we will discuss some other problems of vector. Thank you.